Hello. Today we are going to discuss the uses and applications of the standard friction equation F of S is equal to mu Fn. Friction is a non-conservative force, meaning it tends to dissipate energy. It always opposes the motion or attempted motion of one surface across another surface, is dependent on texture of both surfaces, and on the amount of contact force pushing the two surfaces together. The cause of friction is a combination of molecular adhesion, oh goodness, surface texture, roughness, and deformation effects. Please enjoy the video.
Here we have a block at rest. There is static friction between the block and the table. When a force is applied to the block, it does not start moving until the force is great enough to overcome the static friction. Once it starts moving, it creates kinetic friction and continues to move until the force is not great enough to overcome static friction.
Here we have a block at rest, held up by the force of a hand, not only overcoming the component of gravity, but also static friction. As the hand is removed, static friction is overcome by the component of gravity, and the box is set in motion down the ramp. As the box falls, kinetic friction is in action, and the ball comes to rest by the surface of the table.
Now let's talk about the differences between mu sub k and mu sub s. Mu sub k is a coefficient of kinetic friction, and mu sub s is a coefficient of static friction. Mu sub s is usually greater than mu sub k because it takes a greater force to put an object in motion than to keep it in motion. Mu sub k is a coefficient of kinetic friction which only occurs when two surfaces are moving against each other. Static friction is different from kinetic friction because it only occurs when surfaces are not rubbing against each other. In other words, they do not move.
So, let's take a trip of our test specimen's trip down the slip and slide. Starting at the beginning of the hill, Brock stood still. Getting a running start, he jumped onto the slip and slide, overcoming his static friction immediately, and utilizing kinetic friction as he traveled down the slip and slide. The incline of the slip and slide caused an acceleration of Brock's body, so that when the slip and slide ended and he traveled onto the flat surface of the grass, he was still moving. Kinetic friction acted in the opposite direction back towards the slip and slide as he traveled across the new surface grass, which had a greater coefficient of kinetic energy due to its rougher surface texture. Now let's look at some free body diagrams of Brock while he's in motion. As he's traveling down the slip and slide, the normal force points perpendicularly to his body up. mg, or his weight, points straight down. Force of friction points in the opposite direction of his travel, back up towards the top of the hill. Now, after Brock reaches the grass, the normal force again points perpendicular to his body, and mg points perpendicular to his body downwards. So mg and Fn are pointing in opposite directions. Force of friction acts in the opposite direction again of his travel back towards the base of the slip and slide. First of all, we're going to start with a practice problem and talk about units for our standard equation of friction. So let's start with that standard equation of friction. Force of friction is equal to mu Fn. Now, with my handy dandy stick, our first example, we have a block accelerating due to a 15 Newton force, with the force of kinetic friction acting in the opposite direction of this 15 Newton force. The mass of the block is 10 kilograms, and the coefficient of kinetic friction is 0.001. Now, first of all, we're going to find out what is force of friction and why does mu sub k have no units? First of all, let's start with our parent equation. The force of friction is equal to mu Fn. Now, from our given values, we can plug in that f of f is equal to 0.001 times 10 kilograms times 10 meters per second squared. 10 meters per second squared is our rounded number we'll be using for the acceleration caused by gravity. Now, once we simplify simplify, we can derive that the force of friction is equal to 0.001 times 100 kilogram meters over second squared. Kilogram meters over second squared is also known as a measurement, such as a Newton, represented by the capital letter N, as seen here. Simplify again, and force of friction is equal to 0.001 times 100 newtons. From that, we can simplify once more and solve for the force of friction equal to 0.1 newton. Now, say we knew the force of friction, 0.1 newton, and the Fn from our mass, and we're solving for mu. We start with our parent equation, force of friction is equal to mu Fn. Plug in 0.1 is equal to mu times 100. Plug in our newtons, and we get 0.1 newtons is equal to mu times 100 newtons. Now to solve for mu, we divide out 100 newtons on the right side, and divide the left side by 100 newtons as well. On the right, 100 newtons cancels out, and on the left, the newtons cancel out. And we are left with mu is equal to 0.001 without units. And there you have it. How to find the force of friction in an example problem, and why mu has no unit. Yes!
In this video, two individuals slide towards each other in their socks. The only force acting on them in the horizontal direction is the force of friction, which acts in the opposite direction of their acceleration.
Today we are going to discuss the uses and applications of the standard friction equation F of F is equal to mu Fn. Friction is a non-conservative force, meaning it tends to dissipate energy. It also always opposes the motion or attempted motion of one surface across another, is dependent on texture of both surfaces, and on the amount of contact force pushing the two surfaces together, including the normal force. The cause of friction is a combination of molecular adhesion, surface texture, and deformation effects. I'm ready. Come on. Check my diction. I'm talking about friction, the molecular adhesion, the sweep and the meaning. Got me a surface, apply a force with purpose in any direction. The opposite force will be friction. Let's start with the basics. Some simple shapes, constant surface contact, no air resistance on this planet. It's an ideal situation, just imagine it. Ignore acceleration, constant force to the end. Our equations F of F is mu Fn. To calculate this fate, I need the box weight. Newtons to mg and adult mc. To teach it to you clearly, that's the coefficient of frictional force. Can be as weak as nothing or as strong as a horse. From 0 to infinity, but not beyond. Tough like a rock or slick like James Bond. It's a ratio of identical measure. No units, no confusion, my pleasure. Get back to Fn, the normal trend. Keeps you from falling through the earth, but not off the deep end. But don't let this and friction blend. That's a force in the opposite direction of the applied or intended acceleration. Force of friction is equal to mu Fn. Got it? Get it? Good, write it down. Occurs on every surface, not just the ground. Depends on texture. Applied force and molecular adhesion is a physical sensation that always be creeping. The non-conservative force, let energy seep. Slowing it down, heat making it, surface breaking it. Paddock baked with a mate, test the fiction on tape. Ain't gonna wait, this ain't just a grade. It's our physical fate on Earth, not Planet Holloway.
Hello again. I hereby give my consent to Warlock Holloway to use all recordings, video and audio of myself in order for the purpose of teaching and education in the subjects of witchcraft and physics. No animals were harmed in the making of this video, except my pride, possibly.